Alright, hi everyone. Today what we're going to do, do some ciphering. So it's going to be a three-part series. First part is Caesar cipher. So for those of you that are not familiar with this, a Caesar cipher is just you shift all the letters by X amount. So if you had to shift, for example, A by 1, you will have a B. So A will be B, B will become C, and C will become D, and then blah blah blah, and then Z will become A. So it's a circular kind of cipher. This is what you look like. You just rotate the inner one by X amount when they are aligned. Right now this is a Caesar cipher by 23. So you rotate this way 22 or minus 3, both ways. So A become D, B become E, C become F, blah 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 blah. That's the idea. And we're gonna code this one in Python. So it says write a program that can encrypt text with an alphabetical Caesar cipher. Perfect. So we can enter a number, a symbol, and white space, and we have to make a decrypt function also. Alright, so this is the challenge. Try something, and in a few moments we're going to see what I thought about, what is my solution. This is pretty standard, so you should have something that is a bit similar to mine. So let's do this in Python for this one. So this is what it looks like. It's kind of easy, it's not too hard. You have to play with the ASCII numbers, that's pretty much it, right? So I'm encrypting a message, so this will be my output. That's my variable initialization, and then here this is what I print. I just print the encrypted message. So I start by doing some variable initialization over here. Variable initialization over here. I need the start and the end. Or over here, get the ASCII number of the letter. So here A is 100 and something, and Z is 100 and something also. And what we're going to do, we're going to do plus those ASCII values. So if we're looking at the ASCII table, okay, so A will be over here, 1 in 41. No, actually 97. It will be 97. Right, and then Z will be 122. So if we do a shift by 1, you have to do a 97 plus 1 to get 98, and then blah blah. And when you get to the Z, that is 1 too much, you go back to 0. So that's our start and stop. If the character is less than A or bigger than Z, so meaning anything above this and below that, we don't care, we're not gonna do anything with it. So that's one thing. So character in message, so we go one character by character. So we iterate over here over each character, right? And then we get the ASCII value of it. So this is getting the ASCII value. And then if the character is bigger than start and smaller or equal than end, we can encrypt the thing. Otherwise, we're just gonna put the character back. Say that the encrypted character is the same as the previous character. So if we have a space, a number, whatever, we're gonna put it back over here. Over here, what we're going to do is kind of simple, right? What the first thing you want to do is to remove the offset from the character. So whether it's an A or B or whatever, the number 97, you're going to do minus 97. So if you have an A, you have 0 here, plus the key, which is the amount that you shift. So let's say you shift by 1, you're going to do 0, because A minus A, 0 plus 1, right? Modulus 26, because if we have 27, we want to go back to 0. If we have 26, we want to go back to 0. If we have 27, we're going to go back to 1. And then after that, you're gonna add back the start. That's what you want to do. So let's try with A. we have 97 minus 97, we have 0, plus 1, we have 1, modulus 26, we have still 1, plus start, we have b. Right, let's start with b. You have b minus a, you have 1, plus 1, you have 2, modulus 26, you still have 2, plus the start, so now you have a c, because a plus 2 is c. That's it. This is the only hard part, but that's done. And after that, you just concatenate this to the message, and that's it. Let's test with A, B, C, D, E, F, G. So if we do by 1, we should get B, C, D, E, F, G, H. Let's test that. B, C, D, E, F, G, H. That's it. That's it for the encryption. Now for the decryption, you can think about it, but it's pretty simple. It's the reverse of the encryption. Given the key, you have to shift back by the reminder to get back to 26. If you shift by 26, let's test this. If I shift this by 26, I'm gonna get the same thing, right? So if I shift by 4, that thing, right? If I shift by 4, I want to shift again by 22 to get back to 26. So what you're going to do with decrypt, you're going to encrypt the message again, right? But 26 minus the key. So if you had 26, you're going to do 26 minus 26. You're going to shift again. If you have 1, you're going to do a shift by 25. So that's pretty much it. So if we decrypt this message now, over here, and then you have a 4. That's it. You can decrypt the thing. You can find this on the GitHub account. If you have any questions, just let me know. This is pretty simple. We're gonna do another one in a few moments. But we're gonna change language, so don't be too afraid. We're gonna do it in C, and maybe next time we're gonna do it in MATLAB or whatever, just so that you understand that language doesn't matter too much. So yes, let me know if you have any questions, if you have any comments, just leave them down below, and see you in the next video.